Alright, what's up everybody? It's Mr. Perry here, and today I wanted to take a look at a projectile motion question and really go through the theory of projectile motion. In order to solve any projectile motion, you're going to need these three equations: v equals u plus at, v squared equals u squared plus 2as, s equals ut plus a half at squared. Let's just go through the things that these terms mean. V is the final velocity, u is the initial velocity, a is an acceleration, t is a length of time, and s is a distance, or more specifically, a displacement. So let me throw some information down on this page. If I throw a tennis ball up like that at an angle of 40 degrees, when we measure our angle, let's do the ground here, when we measure our angle, we pretty much always say it relative to the ground. So if I say that an angle is 40 degrees, then what I'm looking for is to say that, where's that paintbrush? There it is. To say that this angle here is 40 degrees. 40 degrees there. What I also need to specify is the velocity with which this tennis ball was launched, and I might say that that's 20 meters per second. Now you think to yourself, well, what can I figure out from that information? And actually you can get quite a lot. The first thing we can do is write out, and this is something I'd always advise, h, in fact let's underline that as well, and then over here write v and underline that as well. Now what this represents is horizontal and vertical, and we can say all of the information that we know. So we break that down into the five things. S equals, u is equal to, v equals, a equals, and t equals. And that's why quite commonly when you use these equations, they're called the Suvat equations. Let's do that there. Brilliant. So now we can start looking at what we actually know. And in this question, we're only really given a little bit of information. We're given the speed and we're given the angle of projection. So what can we fill out then? Well, from trigonometry, which you should have done by now, we know that the horizontal velocity, u, is going to be 20 cos 40. We also know the vertical velocity, the initial velocity, it's 20 sine 40. If you're not sure how I've done that, then you need to go back and look at trigonometry, look at finding the kind of, the x values and the y values of a certain number. What do I mean? I actually mean resolving the vector. So taking this 20 vector, which is a velocity, and resolving it to horizontal and vertical. In fact, I'll just draw those on in blue. So you've got your horizontal component, which is going to be that bit there, and then your vertical component, which is going to be that bit there. And of course this basically creates a triangle, which is this triangle right here as we go around there. Anyway, what else can we figure out? Well, do we know how far it goes horizontally? No, we've got no idea. Do we know how fast it's going horizontally after some time, Well, we kind of do, and the reason that we do know that is the acceleration is 0 meter per second squared. Now you might ask yourself, why is the acceleration 0? Well, it's because when we're traveling horizontally, there are no forces acting on the object. And you might go, well, Mr. Perry, in real life, there's like air resistance and friction and stuff, and I'm going to go, yeah, true, but we don't do real life in physics. We have to do it theoretically, and by making some assumptions, all the calculations just get too complicated. So we could say velocity is 0, not 0, 20 cos 40, it's going to remain the same, but we won't actually bother here. Do we know how high the object goes? No, got no idea. Do we know how fast the object is going at some point? Well, there is one point that I know the object's vertical velocity, and it is 0 meters per second. Let's throw in a unit there, even though we're missing it on some other bits. Now you might say, well, why is it 0 meters per second? And that's because the trajectory, the path that this is going to take, it's going to go up like this, and it's going to come back down over here somewhere. And if you take this point right in the center, we get a nice purple, this point right here, and think about the vertical velocity, well, it was traveling upwards, and then afterwards it's traveling downwards. So in the middle of these 2 points, it must have been at 0. Okay, you imagine throwing a ball vertically up in the air, and you can imagine at its highest point it stops for a split second. Now we can also say the value of the acceleration here, and I'm going to say it's minus 9.8 meter per second squared. Now I've chosen negative because I am choosing upwards here to be a positive value. So anything that goes up for me is positive. Anything that goes down is going to be a negative value. So here is down, and down for me would be negative. And if I make sure that all upwards, what am I doing there? I want to make that, there we go. If I make sure that all upwards values are positive and all downwards values are negative, then everything will come out really, really nicely. And if I solve for something, I get a negative value, I'll know it's heading downwards. Now I'm at a position where I can start to do some solving. I don't even know what I'm looking for here. Like, in a question they'd ask you specifically for something, but really all I'm doing is showing you how you can pretty much find everything that's left now. The first thing we would want to do from our assumption, and remember we're only going up to this purple circle here, is figure out the time taken for that to actually happen. I've got u, I've got v, and I've got a. So if I look across at my equations, I should be able to see, and I think it's going to be this equation here, v equals u plus at, that I can rearrange that, t equals v minus u over a, and I can solve for t. So can we be bothered doing that? No, I don't think I can actually. So what I'm going to do is I'm going to underline stuff when I've solved it. Hopefully you can see, and you guys can do this yourself, that if you take v minus u divide by a, you'll get a value for t. And that's the time taken to get to halfway along. Now this can also give me the highest point, s. Once I've got my value of t, I could use, well, either equation really. I could use this equation, or I could use this equation to find s and find the highest point. So you can go for that as well. Once you've calculated t, you can do that. Now I've got these two values, I've got everything vertically, and now I can find the remaining things horizontally. The first thing to realize is that from our value of t, we can use it to get this value of t. The only tricky thing is that whatever we got for this value of t, let me work it out real quickly. Let me trusty iPhone calculator, because my scientific one is at school. Wow, doing trigonometry on an iPhone calculator seems legit. So I'm doing 20 sine 40 equals, man, these don't work at all, do they? 40 sine times 20 divide by 9.8, I'm cancelling all the negative signs here, gives me 1.31 for t. I said, didn't I, before? So I won't bother working it out. I guess I should have done. 1.31 seconds. The thing is though, that's the time taken to get to this purple point here. So it's only to get that far along. Of course I know in reality that the object's going to go up and come back down. So the time taken to get to the point where it lands back on the floor is going to be 2.62 seconds. And that's because I've doubled the length of time. If it took 1.31 seconds to get to the purple point, it's going to take another 1.31 seconds to get back to the floor. Now you can start to see that I've got probably enough information to solve. Generally with SUVATs, if you've got three terms, you can solve for everything else. I've got u, I've got a, I've got t. I can now find the final velocity with which it hit the floor. But you can see that that will just cancel. That's going to be pretty useless information. V is going to be equal to u, as a is 0. I can, however, find the final displacement. Let's just highlight these last bits so we can get v. V is going to be 20 cos 40 as well. And now I can get s. I know u, I know t, it's 2.62. I know a, so this whole term will disappear, cancel out. S equals ut, so I can do 20 cos 40 times 2.62, which I guess I might as well do. 40, you have to do everything backwards on an iPhone. It's a bit frustrating, but I guess it works. Times 2.62 gives me a total displacement there of 40.1 meters. 40.1 meters. So you can see there, I've very quickly solved for absolutely everything that I have available. And when you look back, you kind of think, well, I didn't really start with very much. I literally started with this black arrow with 20 meters per second written next to it, and this angle of 40 degrees, and I now know everything about this projection. I know how high the tennis ball went, I know how far it went, I know how long it was in the air for, and that's just by making some very basic assumptions, and those assumptions are these two things. The acceleration due to gravity is negative 9.8 meter per second squared. That's constant on the Earth. The second assumption is that when it gets to its highest point, its vertical velocity is 0. The kind of third thing you need to remember is that if you're working out the time to the highest point, the time till it comes back to the floor again is double that value. With all those things, you should be able to work out any projectile motion question. That's pretty standard in 2 dimensions. Hopefully that helped, and if you've got any questions, ask on YouTube or on Edmo.